When you think about strategy, your mind probably jumps to something like chess, right? It's all right there in front of you. You see the whole board, you know exactly what all the pieces do, and you know your opponent's goal is the same as yours. Checkmate. But here's the thing. Real life is almost never like that. Think about our most important strategic decisions. In a negotiation, a business deal, even in dating. We're almost always playing with an incomplete deck. And that's where things get really interesting.
So yeah, this is the big question we're going to tackle today. What is the right move when you're not just unsure about what your opponent will do next, but you're not even sure who they are, what they want, what their goals are, what makes them tick? This is the fascinating world of Bayesian games.
So on the one hand, you've got these games of perfect information. Like we said, think chess. Everything is out in the open, all the rules are known, nothing is hidden. But on the other hand, well, that's pretty much the rest of life. These are games of imperfect information, where everybody's holding some cards close to their chest. It's way more like poker. You know what's in your hand, but you can only make an educated guess about what your opponents are holding. And that uncertainty, it changes everything.
All right, to really get a handle on this, let's use a simple, totally relatable example. We'll call it the dating dilemma. It starts out as a classic game theory setup, but then we're going to throw in a little twist of uncertainty that makes it feel a lot more like real life. Okay, so this is the classic battle of the sexes game. You've got two players who both want to meet up. They get a nice payoff if they end up at the same event. If they go to different places, they both get zilch. The catch? They just have different preferences. Player 1 would rather go to the ballet. They get 2 points if they both go there, while player 2 would rather go to the soccer match and gets 2 points in that scenario. Pretty simple, right?
But now, here comes the twist. What if player 1 has a little doubt? Like, what if player 2 isn't trying to meet up at all? What if they're actually trying to avoid her? All of a sudden, player 1 isn't just playing one game anymore. She's playing one of two possible games, and she has no idea which one it is. And that, right there, is what turns a simple strategic puzzle into a full-blown Bayesian game. Let's put some numbers on this uncertainty. Player 1 figures there's a 50-50 shot. Either she's playing against a version of player 2 who wants to meet up, or she's playing against a version of player 2 who wants to be anywhere but where she is. Her entire strategy now has to account for both of those worlds.
So first, let's look at game A. This is the 50% possibility where player 2 does want to meet. The payoffs are exactly like we just saw. They both win if they coordinate. Player 2 just has a slight preference for soccer. This is the cooperative world. But then you've got game B, the other 50% reality, where everything is flipped on its head. In this world, player 2's goal is to avoid player 1. And look at how the payoffs have changed. Player 2 now gets points for being at the opposite event. This is the conflict world.
Game theorists have a great term for this: player type. A type is just a possible version of a player, and it's defined by whatever private information they have. In this case, what they want. So player 1 doesn't know if she's facing the meet type or the avoid type of player 2. She has to come up with a single strategy that's her best bet against this mix of possible opponents. So how in the world does she decide? Well, she calculates her expected payoff. Let's just walk through it. First, she has to take a guess at what each type of player 2 is going to do. Let's just say the meet type will choose ballet and the avoid type will choose soccer. Okay, now player 1 does the math. If she chooses ballet, there's a 50% chance she meets the cooperative type and gets 2 points, and a 50% chance she runs into the avoidant type and gets 0. Average payoff, 1 point. Now what if she chooses soccer? Well, that's a 50% chance of 0 points and a 50% chance of 1 point. Average payoff, half a point. The rational choice becomes crystal clear: go to the ballet.
That simple story pretty much nails the logic. Now let's just take a quick look at the formal components that make up any Bayesian game. Seeing the building blocks really helps us apply this way of thinking to way more complex problems. So every Bayesian game really has these 5 ingredients. You've got the players, easy enough, player 1 and player 2. You've got the states of the world, the possible realities. Player 2 wants to meet or player 2 wants to avoid. Then you have signals, which are basically clues. Player 2 gives a perfect signal. She knows what she wants, but player 1 is totally in the dark. This leads to beliefs. Player 1's 50-50 probability guess about which state she's in. And finally, you have the payoffs, which tell us what's at stake in every single possible outcome.
Okay, so we've got the basics down. But honestly, this is where Bayesian analysis gets really cool. It uncovers some results that are just deeply counterintuitive. It shows us how strategic uncertainty can lead to these bizarre outcomes that totally defy common sense, like situations where knowing more information can actually make you worse off.
Okay, let's start with a classic paradox. Picture this. You are in a high-stakes auction for a piece of land that might have a ton of oil under it. Nobody knows its true value, but everyone's done their homework. You make your bid, and you win. Your first instinct is to pop the champagne, right?
But wait a second. Let's think about this like a Bayesian. The fact that you won is a brand new piece of information. And what does it tell you? It tells you that every other bidder in that room, every other expert who did their own research, valued that land less than you did.
And this, my friends, is the famous winner's curse. In an auction where an item has some objective value that's unknown to everybody, the winner is almost always the person who had the most optimistic and probably overestimated view of that value. The very act of winning is a giant red flag that you might have just made a huge mistake. A truly rational bidder has to account for this curse and actually bid lower than what they think the thing is worth.
So this leads to an even weirder paradox, one that just completely flips our normal assumptions upside down. I mean, we're always taught that more information is better, right? Knowledge is power. But in a strategic game, that is dangerously wrong. Sometimes knowing less can be your greatest strength.
And this illustrates that point perfectly. Look on the left. Here, player 2 is uncertain about what's going on. Because of that uncertainty, her best bet is to play a safe, predictable strategy. Player 1 sees this, cooperates, and boom, player 2 gets a nice payoff of 2. But now look at the right. Player 2 gets perfect information. So now she customizes her strategy to the specific situation. This makes her actions less predictable, which in turn causes player 1 to play more aggressively. And the result? Player 2's payoff completely tanks. She got more information, and it actually made her worse off because of how it changed the other player's behavior.
All right, let's move on to what is maybe the most profound and, frankly, kind of unsettling example of Bayesian reasoning there is. We're going to apply this logic to the very heart of our justice system, the jury room.
So, here's the crucial insight, and you really have to let this sink in. If you're a juror in a trial that requires a unanimous vote to convict, your individual vote is only pivotal in one very specific scenario, when all 11 of the other jurors have already voted guilty. I mean, think about it. If even one other person votes to acquit, the defendant walks free no matter what you do. Your vote only matters when you are the single deciding factor.
So let's trace the chilling logic here. Step 1. Imagine you're that juror. You've listened to all the evidence, and your private read on it, your signal, is that the defendant is probably innocent. Step 2. You remember that your vote only matters if you're the lone holdout. Step 3. This forces you to update your beliefs based on that condition. You now have to ask yourself a new question. Okay, given that 11 other rational people listened to the same evidence I did and were all convinced of guilt, what does that say about how accurate my innocent signal is? And step 4, the informational weight of those 11 guilty signals can become so overwhelming that it just completely swamps your own private doubts. It can become logically rational to vote guilty, even when your gut tells you the defendant is innocent.
And this chart just shows you how dramatic that update can be. Based on your signal alone, you might think there's only a 20% chance the defendant is guilty. But once you factor in the information that your vote is the deciding one, which means 11 other people are voting guilty, the probability of guilt, given that mountain of new evidence, can skyrocket to 99%.
And that leads us to this really shocking conclusion. The very structure of the unanimous jury system can create a situation where a juror who is acting perfectly rationally votes to convict someone they personally believe is innocent. They're not voting on their own information anymore. They're voting based on the overwhelming information contained in the simple fact that they are the pivotal vote.
You know, this way of thinking isn't just some abstract model for game theory nerds. It's a mirror that reflects our own decision-making. In any negotiation, any argument, any team project you're on, we are constantly, whether we know it or not, making assumptions about what the other side knows and what they want. The big lesson from Bayesian games is that we have to think about their thinking. We have to start asking, what hidden information and what assumptions about me are shaping the games that you play every single day?